What happens when an insect that is a master of camouflage meets a deadly predator that works in stealth and hunts at night? When Rohini, my friend and scientist extraordinaire, started studying these incredible creatures, what began as a puzzling question turned into a story of mystery, intrigue, and some extraordinary evolutionary tactics.
I was looking around for a place to work in the evergreen forest, and so I came into this area around Kudremukh, walking down these paths at night and listening to these incredible calls all around me. This fantastic one that was coming from up in the trees, a whistling kind of call. So I was with my students at the time, and we were laying bets on whether this would be a frog or a bird or a katydid, and my bet was katydid, and I was right. I was just stunned to see how beautiful it was, the false leaf katydid.
The false leaf katydid, also popularly called the false leaf whistler, is astonishingly well camouflaged. When it sits still, it is impossible to spot. And when it flies, it is a piece of art. The female whistler is more than 3 inches long, massive in insect terms. In comparison, the male is a midget. He is only half her size.
I was tracking a particular insect, and I like to track with my ears, so I switched off all the lamps and I was pinpointing the sound source with my ears, and something brushed my cheek. I switched on my headlamp and I saw this bat picking up this large calling katydid, and that set off the train of thought that these insects are calling so loudly, they must be getting eaten by bats.
Bats are the ultimate insect predators. They can listen to their calls, track them using sonar, and completely outfly and outmaneuver most flying insects. The false leaf whistler was certainly being hunted by bats. But which species and how?
And one day while coming back, we saw an abandoned house, and whenever we see an abandoned house, we always look in because we know there might be bats over there. And I still remember it very vividly. So we went into this abandoned house and we looked through the window, and I saw these green leaf wings on the floor, and I said, I found it. Then we went in and looked up to see which bat it was. These are Megadermis spasma, that's the false vampire. Most of their diet consists of insects. And this is the wing of a false leaf katydid. As you can see, it looks exactly like a leaf. And when we started looking at these wings in more detail, the katydid wings, we realized that there were far more female wings than there were male wings in the remains. In fact, almost twice as many. Absolutely, it seems like it's the females that are being eaten more, even though they're silent. Yeah. This was such a puzzle. Why are more females being eaten than males, which is so contrary to sort of common sense?
To find answers, Rohini and her team set up a series of experiments.
So the question we were really asking is, do bats tend to approach calls more than they approach animals in flight, or vice versa?
The first setup was a playback experiment. The team used speakers to play the call of the whistler. They then released bats into the enclosure and measured their response. They found that bats approached the loudspeakers playing the calls about 30% of the times. Next, they wanted to test how often the bats approached a flying insect. For this, they tethered the insect and induced them to fly. The results were a stunning contrast. The bats approached the flying insects 100% of the times. This was all contrary to the established belief that calling was a risky business for insects. If calling was risky, then flying was an insect equivalent of a death wish. If females were being hunted more, did it have something to do with flying?
So we knew flying is risky in terms of bat predation for these insects, but the risk might be different for the males and females, because you can see the females are much larger, so they might be easier to detect by the bats. But on the other hand, it might be difficult for the bats to handle them because they are so big after capturing. So we looked at both bat approaches and the capture probabilities for males and females.
The females are twice as large as males. So you might think that they're easier to detect, they're easier to capture, but no, that's not what we found. A bat is as likely to approach a female flying past as a male flying past. A bat is as likely to be successful in capturing a female as a male. Neither of these can explain why we are finding more females being eaten. That's why we went into the telemetry to say, well, maybe females are moving more across the trees because they're looking for egg-laying sites, looking to find, if she can hear a male on another tree, she has to fly across.
Radio tracking a 4-gram insect needed a highly specialized microtransmitter and a careful pair of hands to fit them.
We waited like 15 years for the tag weights to come down.
The transmitter had only 20 days of battery life. But even in that short period, it provided some valuable insights.
So from the radio tracking data, we see that females are moving more frequently and also greater distances than the males. They are flying 1.6 times more often than the males, 1.8 times longer distances than the males. We think that females are taking more risk because they are flying more than the males, and that could be the reason why we see a female biased predation by the bats on these insects.
The radio telemetry results conclusively showed that female whistlers not only flew more often, but also for longer distances. The mystery of the female bias in predation seemed to have a solution. If flying was so risky and females flew more, hunting bats simply encountered females more often and they took them. That explains the reason why Rohini found more female whistler wings in bat roosts. But along the way, while the team was doing these studies, something serendipitous happened.
In the lab, what we did was to play back the call of the male, and we asked a very simple question. Will they walk towards it? Will they fly towards it? What do they do? What we found was that they do neither. The moment you play the call, the female appeared to go into some kind of tremulatory spasm. I realized it's a tremulation and that they're probably sending a vibratory signal through the branch to the male. We are rethinking about what might really drive why this tremulation signal is because it's really hard to find the male in this huge tree using the sound alone. It's a low-pitched call, and low-pitched calls are hard to locate. But if they tremulate on the wood, it's perhaps easier for the males to come in and locate them. So really the reason they may be tremulating is because it's easier for them to find each other on a tree, not necessarily tied to getting away from bats.